let's talk about angle relationships and similar triangles. Vertical angles. Vertical angles, first of all, always have equal measures, and they occur when you have two intersecting lines. The pair of angles NMP and RMQ are vertical angles. They're stacked. NMQ and PMR are also vertical angles. Now, parallel lines are lines in the same plane that do not cross. When you have another line Q that intersects two parallel lines, that is called a transversal. We have two parallel lines, M and N, and you have a transversal Q, and the angles are inside of the two parallel lines, but alternate sides of the transversal. And alternate interior angles are always equal. Alternate exterior angles occur outside of the two parallel lines, not interior to them, and those angles are also equal. Interior angles on the same side of a transversal, so this angle 4 and this angle 6, adds up to 180. While corresponding angles, they're on the same relative position from the transversal and line N and the transversal and line M. Those are equal. Now, find the measures of angles 1, 2, 3, and 4 given M and N are parallel. Now remember, all of this works only if the two lines are parallel. Now, it doesn't really matter which order you find 2 and 3 in after you find x, but you do need to find x. Now, if we look at this, we see we have two parallel lines and a transversal, and angle 1 and angle 4 are exterior angles, and they are alternate exterior angles, so they are equal. So I'm going to take 3x plus 2 and set that equal to 5x minus 40 and get that x is 21. Once I find out what x is, I can find angle 1 is 3x plus 2, or 65 degrees. Yeah. I know angle 4 has a measure of 5x minus 40, and it's also 65. Angle 2 is the supplement of my angle 1, which is 65. And so it is 180 minus 65, or 115 degrees. Angle 3 is a vertical angle to angle 1, so it is also a measure of 65 degrees. Now, the sum of any measure, the measure of the angles of any triangle, is 180 degrees. So, suppose I have the measure of two angles, 48 degrees and 61 degrees. How can I find the measure of the third angle? Well, I know 48 plus 61 plus x has to equal 180 degrees, or x is 71 degrees. We have three primary types of triangles. Acute triangle, where all of the angles are acute, or less than 90 degrees. A right triangle, where one angle is a right angle, and we always mark it like this with that little corner. Or an obtuse triangle, where we have one obtuse angle. Now, you can't have more than one right angle or more than one obtuse angle in a triangle, since all of the angles have to add up to be 90 degrees, or 180 degrees. We can also classify triangles by their sides. If all sides are equal, they're an equilateral, same lateral side, so an equilateral triangle. If two sides are equal, then it's isosceles. And if no sides are equal, then it's scalene. Now, For a triangle ABC to be similar to DEF, you have to have the following conditions. The corresponding angles have to have the same measure, and the corresponding sides must be proportional. That is, the ratio of corresponding sides has to be equal. Now, these similar triangles aren't identical triangles, but they have these two characteristics. So in this figure, ABC and NMP are similar. Find the measures of B and C. All right, so since we've been told they're similar, we know the corresponding angles have the same measure. Now for corresponding angles, all right, angle A is going to correspond to angle N, angle B is going to correspond to M, and C is going to correspond to P. So N and M, indeed, are both 45 degrees. All right, so since M is 31, what do you think B is going to be? Of course, B is going to be 31. Since P corresponds to C, and P is 104, C is indeed 104. Now, given that ABC and DFE are similar, find the lengths of the unknown sides. Now, we know that similar triangles have corresponding sides in proportion. So what are the sides? AB, all right, so this one right here, corresponds to DF. I recommend you do mark your triangles. All right, and BC, all right, BC, so this long side corresponds to FE. All right, and then the last one, AC, is going to correspond to DF. All right, once you have your sides organized, you see that DE divided by AC has to equal DF divided by AB, or 8 divided by 16 has to equal DF divided by 24. So doing a little arithmetic, we get that cross multiplying 8 times 24 is 16 DF, or DF is equal to 12. Now, since EF corresponds to CB, DE divided by AC has to equal EF divided by CB. So we get this product, this ratio, 18 divided by 6 has to equal EF over 32. So we get EF is equal to 16. Now for the student fact. Workers have to measure the height of a building flagpole. They find at the instant when the shadow of the station is 18 meters long, the shadow of the flagpole is 27 meters long. The building is 10 meters high. Find the height of the flagpole. Very classic problem. We have two similar triangles, so the sides must be proportional. So I have MN, which is what I'm looking for, that's my height, divided by 10 has to equal 27 divided by 18. Solving. I get MN is equal to 15. So the flagpole is 15 meters high.